So now let us discuss diagonalization of a matrix. So we are going to have a matrix. Ultimately, we are going to obtain a diagonal matrix through similarity transformation. Okay, through similarity transformation, we are going to use that formula. Which formula? This formula. We are going to use this formula, and we are going to obtain one matrix. That matrix will be diagonal form. That's called a diagonalization. Okay, so diagonalization of a matrix A is a process of reduction of A to a diagonal form. Okay, for example, you have a matrix. We are going to use this formula, which is nothing but similarity transformation from one basis to another basis. So D will have one basis and A will have another basis. So through this similarity transformation, we are going to change from one matrix to another matrix. Both will have same trace, same eigenvalue, same determinant, same rank. So all those properties are invariant. So those are called similarity transformation. And we are going to reduce a matrix into a diagonal form. Diagonal elements alone will exist. What we call this process is nothing but diagonalization of a matrix. So matrix diagonalization is the process of transforming a square matrix into a diagonal matrix through a similarity transformation. Those matrices are called similar matrices. Specifically finding an invertible matrix P. So there exists the matrix P should have inverse. Invertible matrix means inverse matrix. And a diagonal matrix D such that A equals P D P inverse. Or otherwise you can say D equals P inverse A P. See, A equals P D P inverse or D equals P inverse AP. Is it okay? Where A is the original matrix. This transformation is possible if and only if the matrix has a complete set of linearly independent eigenvectors. So this must have or should have linearly independent eigenvectors. What are the steps of diagonalization of a matrix? The first step will be we have to find out the eigenvalue. Determine the eigenvalues lambda of the matrix A by solving characteristic equation det A minus lambda equal to 0. So you have to solve the matrix using this det A minus lambda I to find out the eigenvalues. Second one will be eigenvectors. For each eigenvalue, you have to find out corresponding eigenvector. The corresponding eigenvectors by solving the equation A minus lambda I x equal to 0. Here it is V, doesn't matter. So A minus lambda I x equal to 0, where x or V is the eigenvector, which will show the direction, which is invariant, we said. Form the diagonal matrix. Now we are going to form the diagonal matrix. Create a diagonal matrix D with the eigenvalues of A along the main diagonal. We will see one by one. Find the eigenvectors. So you have to find out the eigenvectors. Next one will be form the model matrix. So we are going to find out the eigenvectors. Now put together, that will give you model matrix. That is nothing but your P. Okay, model matrix. So A is reduced to the diagonal matrix D through a model matrix P. We are going to construct the matrix P by using the eigenvectors of A as its column. So we have three eigenvectors put together, that will give you model matrix, which is nothing but P. Now we are going to calculate. We are going to use this formula P inverse AP, which is nothing but similarity transformation formula. If the result is a diagonal matrix D, then the diagonalization is successful. So we will get only the diagonal form. The matrix will be in the diagonal form. Only diagonal elements alone will exist. So this is the process. Eigenvalue, you have to find out eigenvalues, eigenvectors, then put together, you have to go with the model matrix, then you have to find out P inverse. The formula is P inverse is this one, and you have to use this formula P inverse AP, which is nothing but your diagonal matrix. So that will be in a diagonal form. The process of finding P such that P inverse AP D is called a diagonalization of a matrix. A square matrix A is said to be diagonalizable if there exists a matrix P such that we have to use this formula. Okay, similarity transformation formula, which is a diagonal matrix. Again the same steps. So step 1 we will have to find out the eigenvalue, eigenvectors, correct? Matrix will be given. we'll have to find out the eigenvalues, eigenvectors. Then after that, put together, that will give you a model matrix. Then after that, you are going to find out P inverse. Use this formula to get the diagonal matrix. We'll solve one problem. Diagonalize the matrix. So A is given as 1, 1, minus 2, 4. Very simple one. So first one is, we'll have to find out the eigenvalue. We'll have to use this formula, that A minus lambda I equal to 0. So your A is here, minus lambda I is here. So that will give you 1 minus lambda minus 1. This one is 1 minus 0, so that will be 1. And here it is minus 2. Here it is 4 minus lambda, which is equal to 0. Cross multiplying will give you 1 minus lambda, 4 minus lambda, minus 1 multiplied by 1, already 1 minus is there, so plus 2. Then simplifying, you will have lambda squared minus 5 lambda plus 6 equal to 0. We are going to factorize now. So 6 can be factorized into minus 3 multiplied by minus 2. Okay, minus 2 multiplied by minus 3. So 2 3s are 6. Minus 2 minus 3, that will be minus 5. See, minus 5. Okay, so 2 and 3 are eigenvalues. So first step is over. We have found out the eigenvalues. Next step will be eigenvectors. Very good. So for lambda equal to 2, you just substitute in the A minus lambda I, that matrix, and to find out the eigenvector. So this multiplied by x1 and x2. So substitute here for lambda equal to 2. So you will have minus 1, 1, minus 2, 2, x1 and x2. And this one will be minus x1, correct? And this 1 multiplied by x2. So minus x1, which is equal to minus x2. See, minus x1 plus x2. So minus x1, which is equal to minus x2. Minus minus will go off. So x1 equal to x2. If x2 equal to 1, x1 will be 1. So 1, 1. Or otherwise we'll go for the next one. Minus 2x1 equal to plus 2x2. You bring this term to that side. So minus 2x2 minus minus 2 will go off. x1 equal to x2. So x2 equal to 1. Your x1 will be 1. So 1, 1. Is it okay? Simple. Now you go for lambda equals 3. You substitute here. If lambda equal to 3, you have substitute for lambda. So 1 minus 3, that will be minus 2. So 1 as it is. Minus 2 as it is. 4 minus 3, that will give you 1. So x1 and x2. Minus 2 multiplied by x1 will be minus 2x1. 1 multiplied by x2 will be this. Okay. Similarly for the second one, the equation goes like this. If 2x1 equal to x2. 2x1 equal to x2. x2 equal to, if x2 equal to 1, we will have, if x1 equal to 1, we have x2 equal to 2. So that will give you x2 equal to 1, 2. Either way you can do it, doesn't matter. You will get the same answer. So x2 will be 1, 2. So we have found out the eigenvector for the first eigenvalue, eigenvector for the second eigenvalue. Put together, that will give us model matrix. So this is your first eigenvector, that will be your second eigenvector. The model matrix is this one. Your P is your model matrix. 1, 1, 1, 2. So to find out the inverse, so P inverse, we will have to use this formula, H P divided by mod P. So you have P inverse is this one. So 2 minus 1 minus 1, 1. As I told you earlier, you just change the diagonal. See, we have changed the diagonal, correct? Change the sign. See, change the sign. You will get it. Is it okay? See, this is your P. This is your P inverse. Change the diagonal element. Change the sign of the off diagonal elements. Minus 1, minus 1. Now, D equals P inverse AP. Similarity transformation formula. Okay, to diagonalize the matrix. So P inverse AP. You multiply these two matrices, you will get this. You just keep this matrix as it is. Multiply these two matrices, you will get this. 4 multiplied by 1 minus 2 multiplied by 1. So answer will be 2. 4 multiplied by 1 minus 2 multiplied by 2. So 4 minus 4, 0. See? And this one also will become 0. The last one will be minus 3 multiplied by 1, 3 multiplied by 2. So 6 minus 3, answer is 6. See, this is the diagonal form. We have diagonalized the matrix. D. What are the trace of the matrix? 5. The trace of the matrix A also will have 5. The same thing. Okay. See, trace of A 1 plus 4. This is your A matrix. 1 plus 4. Here also 2 plus 3. Determinant. What is the determinant? Determinant is not equal to 0. So rank of the matrix is 2. Determinant is not equal to 0. Rank of the matrix is 2. Okay. So we'll have same determinant, same eigenvalue, same trace, same rank of the matrix. So A and B. Here it is B and A are similar matrices. Okay. Any doubt in the previous problem? So we have come to the diagonal form of a matrix. Diagonalize the matrix A equals 2, 6, 0, minus 1. So now we are going to use the different method. We are going to use this formula, lambda squared minus S1 lambda plus S2 equal to 0, where S1 is the sum of diagonal elements, which is nothing but 2 minus 1, which is equal to 1. S2 is det A. So det A is nothing but minus 2. 2 multiplied by minus 1. So which is nothing but minus 2, correct? Minus 2, then this becomes 0. So minus 2. Characteristic equation is given as lambda squared minus lambda, then this will be minus 2 equal to 0. So we have to factorize minus 2, that will be plus 1 and minus 2. Multiply will give you this. Add 1 will give you minus lambda, correct? So your eigenvalue will be minus 1, 2, plus 2. So these are all eigenvalues. Next one will be eigenvectors. So to find out the eigenvectors, we have to use this formula A minus lambda x equal to 0. So lambda 1 equal to minus 1. We have to substitute the first eigenvalue. So lambda 1 equal to minus 1. Substitute in this equation. So we have 3 minus of minus 1. So 3. Here it is 6. It is 0, 0, x1 and x2. You pull 3 out here. So that will give you 1, 2, 0, 0, x1 and x2. And this becomes x1, which is equal to minus 2x2. If x2 equal to 1, x1 will be minus 2. So minus 2 and 1. So this is your eigenvector for the first eigenvalue. For the second eigenvalue, use A minus lambda x equal to 0 and you pull, here it is 3. You can pull 3 out. So this becomes 2, this becomes minus 1. And you have 0 multiplied by x1, 2 multiplied by x2. So if x2 equal to 0, x1 also will be 0, so we have to assume 1. So this becomes 1 and 0. So x2 will be 1, 0. The model matrix, P model matrix, correct? Here it is B, okay? So don't get confused. You just follow the uniform method. So that will be 1, 0, minus 2. See, 1, 0 I have written like this, and your minus 2, 1 is here. So find out B inverse. But usually we will give a symbol as P. Don't forget, this is P. Okay. So B inverse, how to find out B inverse? The same method. You have to change the diagonal elements, change the sign, you will have B inverse. So D equals B inverse A, B. So your B inverse is here, A is here, B is here. Now you will have to just multiply these two matrices, you will have this answer, and this matrix, let it be like this. Again you multiply these two, you will have this matrix. So look at this matrix, only diagonal in the diagonal form, 2 and minus 1. All diagonal elements are 0. Here also 0, here also 0. So 2 and minus 1 and 2 are eigenvalues of the original matrix A. And here 2 and minus 1 exists. So again this also will have same diagonal, same eigenvalues, same rank, same determinant, same trace of the matrix. Okay, that's the rank of the matrix. Is it okay? So diagonalize the matrix A equals 3 minus 1 minus 1, 3. Use the formula to get the characteristic equation, lambda squared minus S1 lambda plus S2 equal to 0. Your S1 is nothing but sum of the diagonal elements. So 3 plus 3 equal to 6. So S2 will be determinant of A. So that will give you 9. plus 1, so minus 1 will be there, so minus 1 which is equal to 8. Substitute the values of S1 and S2, we will have this. So 8, we are going to factorize this 1, so 8 will be minus 4 multiplied minus 2. Add these two will give you minus 6. Multiply these two will give you plus 8. So lambda minus 4, lambda minus 2 equal to 0, so lambda equal to 4 comma 2. So those are all eigenvalues. So first we will go for lambda, first eigenvalue, lambda 1 equal to 4. So this is your a minus lambda x equal to 0, that formula. So a minus lambda x equal to 0. So you substitute for lambda 4, you will have 3 minus 4 which is equal to minus 1. So minus 1. Minus 1 let it be, minus 1 also let it be. 3 minus 4, that will be minus 1. So multiplying these two, that will give you minus x1 minus x2 equal to 0. So x1 equal to minus x2. If x2 equal to 1, x1 will be minus 1. See, 1 and minus 1. If x2 equal to 1, x1 will be minus 1. So minus 1, 1. So this is the eigenvector for the first eigenvalue. Similarly, you can get the eigenvector for the second eigenvalue using a minus lambda x equal to 0. A minus lambda x equal to 0. So we have x1 minus x2, x1 equal to x2 we have. So if x2 equal to 1, x1 will be also 1. So x2 will be, capital X2 will be 1, 1. So to find out the model matrix, you just put this eigenvector and that eigenvector which you have found out in a matrix form. See here, minus 1, 1, 1, 1. See, minus 1, 1, 1, 1. So this is your model matrix. So we have to find out B inverse. So as I said earlier, you have to change the diagonal and change the sign. You will have this. So you will have this. Okay. So some other way also we can find out. So we have found out determinant B is this one. H B is given as this. So B inverse equal to this. So we have found out now B inverse. So B inverse multiplied by A multiplied by B. So we have, first we multiply these two. So multiplying these two will give you this matrix. Then after that, this answer is here. Multiplying these two will give you this answer. Okay. See, multiplying these two will give you this answer. Minus 3, minus 1, it's nothing but minus 4. So minus 4, 4, 2, 2, here minus 1, 1. Now you are going to multiply these two will give you minus 4 multiplied minus 1 will give you 4. 4 multiplied 1 will give you 4. So 4 plus 4, 8. Here it is 0. Here also it is 0. Here it is 4 again. So 1 by 2, 8, 0, 0, 4. Divide by 2 will give you 4, 0, 0, 2. See, 4, 2 are your eigenvalues. See here, 4, 2 are our eigenvalues. 4, 2 are eigenvalues. Earlier which you have found out. So eigenvalues are the same. Determinants also same. Trace of the matrix. Okay. So those properties are invariant. Under similarity transformation, those matrices are called similar matrices. The last one will be your assignment. Oh, this is another example. Okay. This process is known as diagonalization of the matrix, and this is used for powers of the matrix. So one can also find out the powers of the matrix. So let A is given as this. We are going to find out A to the power k. A to the power 3 or A to the power 4 or A to the power any number. So any number. Now of course A is given as PD P inverse. So we have found out already D. D is the diagonal form. So we have already found out. So it is given as this one. And P inverse also is given. So P inverse. You can find out P inverse now. You have to find out the eigenvalue, eigenvector, find out the model matrix P. So P inverse you have found out. So this is your assignment. Okay. This is the given matrix A. You have to find out the eigenvalue. How many eigenvalues will exist? 2 eigenvalues. This is 2 by 2 matrix. 2 eigenvalues. Then you will have to find out the eigenvectors. Put together will give you model matrix. After that, use the formula D equals P inverse AP will give you D, diagonal form. Is it okay? So these are all your assignments. You have to find out. Now P inverse, we have found out P inverse. Now we are going to find out the powers. A squared equal to A multiplied by A. P D P inverse, P D P inverse. P inverse P will give you identity matrix. P inverse P will give you identity matrix. This D material D will be D squared. So we have P D D P inverse. Is it okay? So P D squared P inverse. So your P is here D. D is a diagonal form. Square is nothing but 25 9. So 2 1 minus 1 minus 1. Similarly, a to the power 3. A to the power 3 is nothing but a multiplied by a squared. A squared already we have found out. See here, a squared is this one. So a multiplied by a squared will be P inverse P is again identity matrix 1. So D squared will be DQ. So P DQ P inverse. So similarly, any power will be a to the power k equal to B P D to the power k P inverse. So any power can be obtained easily. Okay. So this is also very important application for diagonalization. Okay. Last one. So this is your the last one. This is your assignment. See here, A matrix is given. You will have to find out the eigenvalues, eigenvectors, model matrix. You will obtain D here. This is your eigenvectors. This is your model matrix. You will have to find out P inverse A P. P inverse AP will give you diagonal form, diagonal matrix 2 1 minus 1. Okay. So some steps are missing. You will have to find out. So this is your assignment. See, A matrix is given. You will have to find out the eigenvalues. Use det A minus lambda equal to 0. You will have to find out the eigenvectors. A minus lambda x equal to 0. Put together, that will give you model matrix. Use similarity transformation formula. Find out the diagonal form. So that is your assignment. And of course, this matrix and this matrix are similar matrices. Okay. So we will see in the next class. Thank you, students.